Welcome to the Chapter 2 lecture for the Management 3120 Operations Management course. I am Dr. Bill Perkins, and I'm going to provide you a video lecture based on the material found in the textbook Practical Operations, 2nd edition from Natalie Simpson and Philip Hancock. So we're going to get started. Our objectives for this chapter is to develop an understanding of operations strategy, be able to classify products and processes, and be able to calculate productivity. Before developing any goals, a business must first determine what it desires before it can plan how to achieve those goals. In general, a strategy is a long-term plan committing a person or organization to a particular path towards certain goals. Now, businesses determine the what and the how through strategic planning. That is, the goals and the path to achieve them. Therefore, a strategy is a methodology and resulting plan that identifies the long-term goals of an organization. Now, when businesses pause to consider the future, their strategic planning is expected to flow through a series of stages. We'll start with the vision, which is where the organization is going. An organization's vision statement provides the why and where, describing the future that represents the organization's overarching reason for existence. Now, vision statements usually dedicate the business to some broad picture of the future. Now, on page 37 of the textbook, there are sample vision statements I want you to take a look at from some very popular organizations you all can relate with, and I'm sure you can identify with the actual vision statement and the organizational purpose. I want you to read them, and you'll see what I mean by defining a vision statement as an organization's defining statement about the future. So here we are. Your vision is an organization's defining statement about the future. You want to take a note of that. Next, the mission explains how the organization will get there. A mission statement establishes how an organization is going to create its vision of the future. Much like the sample vision statements, they're on page 37 of the textbook, you can also identify what some of the organizations and their vision and mission. See how that mission corresponds with their vision. So a mission statement, or a mission, rather, is an organization's statement about what it's doing to meet its vision. Now, values drive how the organization will conduct itself and its mission. Most organizations establish what they call core values that are socialized throughout the organization that shape behavior in accordance with strategies. Having a core value of integrity, which seems to be a popular core value, should foster ethical decision making, doing the right thing when nobody's looking. Another example would be diversity, which would cultivate the inclusiveness organizations need to improve innovation strategies, morale, and equal treatment of employees. An organization should state its core values alongside its mission and vision. Make sure there's an integration of them when you're affecting your vision and your mission. A value statement specifies the principles that will determine how the organization behaves in achieving its vision and mission. The emphasis of a value statement is on behaviors and ethics that shape decision making as the mission statement flows into detailed policies and practices. Once the highest level vision, mission, and value statements are formulated, the strategic planning process can begin. So once vision, mission, and values are declared, operations moves an organization towards its envisioned future, following the path defined by the mission and vision statements. Many strategic decisions at this point translating earlier strategy statements into actionable plans for the organization. Now, during this translation, operations strategy must identify and clarify the products to be offered and how these products will compete for customers. Choices made here then inform strategic selection on processes to create these products to best use existing resources in pursuit of the vision and mission. Now, this use of resources must then be measured and monitored as it represents the vital issue of productivity. Now, business plans flow from the vision, mission, and value statements of an organization. Now, here, decision-making begins to combine internal conditions such as available resources with the external environment, such as interactions with customers, competitors, and government regulations. Large organizations often establish both corporate and business unit strategies from the earlier phases of strategic planning, creating the branches visible here at the bottom of figure 2.1. Now, corporate strategies further define the area of business in which the organization will compete overall and allocate its internal resources to support that strategy. Now, large organizations are often divided into smaller business units. It is not uncommon for each of these units to then develop a vision, mission, and business strategy, all adopted from the broader organizational decisions made earlier. So a lot of times, essentially, you'll have these micro or derivative vision, mission statements that will overall have the main organization's vision and mission realized. So that's pretty common, what you'll see. However, at that point, that different divisions, business units, or departments all express individualized versions of some larger plan, the problem units or departments all express individualized vision and mission statements, like I said earlier. Goal alignment at the bottom of figure 2.1 is achieved if all the separate plans are compatible with each other and support the planning illustrated on this diagram. Now, one common example of weak goal alignment is two business units separately deciding to compete in the same market, placing them in direct competition with one another. That does happen, and that's a clear illustration of poor communication. Another example is each of the two business units deciding on a major capital investment, such as a factory expansion, when they could coordinate or share the investment to benefit of the larger organization. So good goal alignment cannot be achieved without good communication across the entire structure of the organization, which is a requirement that presents greater challenges as organizations become larger and internally more complex. Although technology has transformed manufacturing, not all modern mass manufacturing relies on sophisticated equipment instead of people. For example, you have denim jeans here. They are assembled through largely manual processes such as rivet setting, as seen here in this picture. Now, following the trend of globalization covered on page 41 of the textbook, much of this processing has shifted and been concentrated in countries offering the lowest cost of labor critical to this type of production. Furthermore, much of this work has shifted as subcontracting, in which the original organization hires a local organization to produce on its behalf. Now, in some cases, this has put the corporate value statement at the center of a new controversy. If the quality of life of a subcontractor's employees is not consistent with the values that an organization dedicates itself to on behalf of its own employees, is that organization upholding its own values? Now, if not, then does this responsibility stop with the first subcontractor, or does it extend further along the supply chain? And if so, how is the original organization to know what values are practiced by the subcontractor suppliers with whom it has no direct contact? And I want you to just take a second and, I want you to kind of reflect on your own thoughts here about this. Now, do you think organizations who either engage in outsourcing with other organizations, use subcontractors, do you think that they are responsible for that organization or even person with their values? Now, large corporations often organize and evaluate themselves according to their output, creating internal divisions dedicated to certain markets or certain product lines or both. Whereas this is a sensible and functional framework, it can hide a critical issue to the long run success of that company, which is its core competency. So a core competency is a distinct set of abilities unique to that company, the theoretical source of its competitive advantage. So by definition, a core competency is a specific ability that distinguishes a business from its competitors. It does not necessarily reside in a single division of a large organizational structure. And I want you to consider Honda Motor Company. Its worldwide production includes competitive offerings in automobiles, motorcycles, electrical generators, outboard motors, off-road vehicles, and lawn equipment. However, when you look at that and you look at all those products, its core competency does not concern with any of these products in particular. Honda is recognized globally for engines and powertrains. So it's a little bit more specific to its purpose, and that lies at the heart of each of the products mentioned. Now, by definition, competitive strategies should follow from core competencies, and core competencies themselves are usually found in operations because they reflect the capabilities of a system. Furthermore, identifying a core competency within a complex system is vital for reasons beyond simply identifying the source of the system's current success. Now, core competencies are believed to power the development of new products, as reflected in Honda's innovative expansion into diversity of uses for internal combustion engines. A core competency, if unrecognized, can also be eroded by outsourcing of processes critical to the competency. A decision that might appear sensible if those processes are considered only in isolation. However, once an organization has declared its core competency, it typically chooses one or more specific dimensions on which to develop its competitive strategy further. Just like how Honda got into automobiles, motorcycles, outboard motors. That's a good example of that. Now, minimizing the cost of a product would seem a logical strategy for competitive advantage, either to pass the savings to the customer and win market share, or to increase profitability on the same base of sales revenue. However, intense competition for customers based on costs is most closely associated with mature products, as we discuss later in this chapter. Although any business would be foolish to completely disregard the issues of productivity and cost savings during operation, pursuing a lowest cost goal alone is not usually enough to remain competitive. Some organizations distinguish themselves with the speed of their operations, and these organizations may or may not compete through cost as well. They're not the same. Customers expect low cost and high speed when choosing a fast food restaurant, for example, whereas they would pay more for fast delivery when choosing a shipping company. Speed and cost are often linked, and speedier performance may even lower an organization's costs by lowering inventory levels or increasing production from the same infrastructure base. Interestingly enough, a reputation for speed and a reputation for on-time delivery are not always the same issue, as an organization can choose reputation for on-time reliability, always delivering according to the schedule, but not necessarily providing the product quickly. An example of that would be a cable company. A cable company would provide in-home installation, allowing the homeowner to better coordinate, that window of time. However, that window of time may be weeks after the homeowner orders the service. A fast provider is not necessarily a responsive organization, as responsiveness measures the overall effectiveness of the organization in meeting the customer's particular needs, not simply its promptness. The greater the complexity of individual requirements and/or volatility in customer demands, the greater the challenge of successful response. Organizations that choose to compete through responsiveness must cultivate flexibility within their operations because they cannot know in advance precisely what will be required of them. A lot of it is done through, consumer behaviors, need of product, elasticity of demand, and so forth. Many organizations compete through product quality. Luxury goods are an obvious example. Customers expect these products to contain premium ingredients and to conform to exacting specifications. Quality, however, is more complex than premium goods and first-class service. Competing on quality may overlap heavily with responsiveness, as an organization strives to serve an individual's exact tastes. However, competitive product quality doesn't necessarily require a customized product, as demonstrated by McDonald's, which launched the fast food industry by demonstrating the competitiveness of a narrow, inflexible menu of low-cost food items delivered with unfailing reliability. And this reliability is itself a power form of quality, in that quality is ultimately measured by the customer satisfaction with the product. Consistency and reliability allow a customer to plan around a product, confident exactly of what will be received. A feature that may prove critical to high satisfaction and loyalty to a particular provider. Product quality is also far more difficult to assess than speed or cost because it is ultimately determined by human perception. As a result, customer perception of a product's quality may be influenced by factors not directly related to that product, such as cleanliness of a lobby where the customer waited before entering a facility, or the greeting from a receptionist there at the organization. Even though an organization chooses one strategy, or perhaps a combination of cost, speed, and responsiveness and quality to distinguish itself from its competitors, this does not mean that the other dimensions can be ignored. Logically, the fastest and highest quality product in the world will not succeed if the customer cannot afford it, nor will the lowest cost product succeed if it does not meet the customer's needs. Now, this raises the distinction between order qualifiers versus order winners, a useful model of the inner workings of competitive advantage. Now, order qualifiers are the minimum standards that an organization must achieve to simply be considered by the customer. Now, for any given product, every dimension discussed here suggests an order qualifier, such as priced no higher than $10, delivered on the same on some time that day, or available online. Order winners, however, are further requirements that provide competitive advantage over other businesses that qualify, such as lowest price, or includes choice of colors. Order winners, as the name suggests, are the dimensions that an organization prioritizes to win customers' business. Now, order qualifiers are theoretically mandatory for all organizations in the market, but these requirements have been known to change over time. Previously successful organizations can suddenly lose market share if they fail to notice that that some competitors' order winner, such as the option of electronic payment, has evolved into an order qualifier in the mind of the customer. Even the organization that first introduced that order winner with great success can lose its competitive advantage if it fails to notice this change. Its previously successful strategy is no longer distinctive. Now, organizations are defined by their products in the minds of the public, such as Domino's being a pizza franchise, or the Red Cross being disaster relief. However, the success of such organizations are often determined more by how they provide product than by the goods being delivered. Now, core competency and competitive strategy should dictate an organization's product, but this alone does not decide what processes will be needed. Product selection and process selection are distinctive strategic decisions. Now, for the purposes of this course, processes will be defined as activities that transform inputs into outputs. Now, the product choices of an organization are usually quite visible, as these are outputs it offers to its customers. Now, products can be anything deliberately created from inputs, from printed circuit boards to petroleum, to financial consulting. That's right, even the service. Consumer products fill the shelves of retail stores, yet these are usually the products of distant manufacturers, not the retailer offering the goods for sale. The retailer's products is the convenient availability of the manufacturer's product as service to the customer. Note that the retailer selects a process through which to make the product available, deciding how to transform its resources into successful sales. Retailers like Walmart build multiple stores and focus on sales through in-person shopping, while retailers such as Amazon focus on making some goods available through online shopping and parcel shipments. Other industries provide more examples of multiple processes supporting the same product, such as the choice between satellite uplink versus land-based cable networks for data transmission and home entertainment, or the choice between microwave energy versus convection heating for rapid food preparation, whereas options such as microwave versus convection are specific to certain businesses. It is important to remember that all industries face similar strategic choices during the process selection, often expressed as some compromise between make to order and make to stock. So one highly strategic choice is the degree to which a product will be customized. A customized product places added demands on a process because each product is unique meeting the specific requirements of a particular customer. Creation of the products in this fashion is known as make to order, which often requires that the customer waits while the product is being created. Emergency surgery, tailored clothing, most building construction, and carrier jet services are all examples of customized production processes. So when goods are produced through a highly customized process, they are often recognized as handcrafted, requiring skilled workers. Selecting a make-to-order process strategy implies that responsiveness will be a particularly powerful order winner in the customer's eyes, because this type of process cannot compete strongly based on speed or low cost. Now, most modern consumer products are not individually customized to the consumer's preferences. Most providers of everyday items have adopted a high degree of standardization in their processes, removing the flexibility to create specific features for individual customers. Now, this allows a mass production of similar items in which the case of goods tend to accumulate before sale. In this potential accumulation of high volumes of output for later consumption, that is the origin of the term make to stock, as you see here in the box to the right. The opposite of a make to order process. So as an example, modern beverage bottling facilities often measure their product output rates in hundreds or even thousands of bottles per minute, and thus are capable of filling vast warehouses when finished stock daily. The make-to-stock approach may apply to services as well, although the term in this context is a bit confusing because services cannot literally store their output as inventory. Nevertheless, one example of this approach in services is a specialized automotive service shop such as Jiffy Lube franchise. Now, these garages, by offering a narrow range of stock maintenance services such as oil changes, investing in specialized equipment to provide these service products quickly. In contrast, full service garages are often stocked with more generic equipment for automotive repair, but the skilled mechanic in those private mom and pop shops, in residence, provides a wider variety of repair service than you would get at a Jiffy Lube, and it would be customized to the particular need of each vehicle. So almost all goods productions was essentially make to order until a few centuries ago. Now today, make to order is an optional process, and many skilled people still provide individualized goods for clients around the world. In this picture, a craftsman builds electric guitars. Now, even though the same product is mass manufactured elsewhere, consumers who purchase guitars here expect to pay more if they purchase from standardized retail stock, but also expect their more expensive purchases to conform more closely to their individual tastes. Now, this is an essential trade-off between make to order and make to stock production, true for almost any consumer good. When processes are arranged without a particular flow pattern required when moving work between them, this choice is known as a process layout, a configuration in which transformation proceeds along multiple shifting patterns throughout the facility. It's not necessarily one conveyor belt taking you through an easy process. It'll be multiple processes, however, in the most efficient patterns. Process layouts are also known as job shop. Now, not all choices of product and process make sense, and certain patterns of successful combinations are well known. These are often described with models such as the product process matrix, perhaps the best known in all of operations management. In the late 1970s, researchers Hayes and Wheelwright organized their observations of manufacturers into a two-dimensional map to compare what was being produced, product choices, that is, what was being produced with how it was being produced. Now, the resulting product process matrix appears here on this slide in figure 2.3. The position of a particular business is determined by first noting the degree of standardization of its product, while the standardization versus customization of what is being produced determines the horizontal placement. How the processes are structured for its production determines its vertical placement. So while the standardization versus customization of what is being produced determines the horizontal placement, how the processes are structured for its production determines the vertical placement. In the previous slides, we covered process layout in job shop, which is illustrated here in the vertical axis. And it makes sense when you think about sugar refinery being a continuous flow in comparison to heavy equipment requiring a process layout. Now note how the example businesses provided in figure 2.3 here creates a line from the upper left to the lower right of the matrix, an area known as its efficient diagonal. One lesson of the product process matrix is that a business should be careful not to wander too far from the diagonal, because these are the combinations of product and process choice that are not likely to be successful. For example, a business using a highly flexible job shop to build large amounts of identical product would be located in the upper right corner of the matrix, but this business wouldn't likely survive because its standardized product could be produced faster and more inexpensively on, let's say, an assembly line. Okay, so it really would be placed to the lower right. Likewise, a business that chooses to build unique make-to-order items on a high-speed, highly connected assembly line will struggle to produce because the process structure is too rigid to accommodate every request of every customer. So the product process matrix also highlights how managerial problems will vary depending on where the business is positioned on the diagonal, and thus performance measures should also change with the position. Now, firms on the lower right are best placed for highly efficient production and should be measured for such, but not expected to be flexible, adaptable, and responsive, which can be required of lower volume firms higher on the diagonal. This clarification is particularly helpful to large organizations with multiple business units operating at different positions within the matrix. Now, the product process matrix was created by observing manufacturing firms, so it works best in those industries. It is not unhelpful to service industries, but its correlation of what to how is less insightful in situations where the phrase "make to stock" itself makes little sense. So, in response, the service process matrix illustrated here in 2.4, figure 2.4, was developed specifically for services. The horizontal axis here is similar to the original product process matrix. The degree of variation witnessed in a service product is largely, but not completely, driven by the degree of customization of that product. Likewise, the vertical axis refers to the process choice, but asks a less specific question of throughput time or the general speed of the process. If you hear throughput time throughout the text, you're looking at the general speed of the process. The more time required to provide the service product, also known as its lead time, the lower the provider should be placed within the map. Now, although the service process matrix has an efficient diagonal similar to its predecessor, issues of efficiency versus flexibility run in the opposite direction to the product process matrix. So the service process also clarifies how the same service product may be offered with different process setups. So figure 2.4 uses food service as an example, where a typical family restaurant is a good example of a service shop, providing somewhat customizable meals with personal service in a reasonable amount of time. A customer who wants to pay less and get faster food can eat at a fast food franchise or buy from a vending machine, which are examples of service factories that achieve savings by offering less variety. Now, in contrast, a customer with a unique dietary need may dine at a gourmet restaurant, as this establishment emphasizes the professional services of the chef and the staff more so than the speed of production. So whereas customers do have many choices when purchasing automobiles, they usually buy this product from existing stock. Most automobiles are mass manufactured by relatively few producers when compared to a century ago, when 75 companies built automobiles in the United States alone. Highly efficient automation processes have brought production costs down when compared to earlier automobile production, but this picture hints at the high level of capital investment when it becomes necessary to establish high volume, standardized production. So now we're going to go to shift to the product's life cycle. And the product life cycle is a generalized pattern of phases in product demand over time, from incubation to decline. Now, the preferred choice of process may also be influenced by the age of a product. Now, this observation is motivated by the product life cycle, which is a marketing model that divides the sales history of any product to phases similar to that of a biological organism. When the historical sales of a product are aggregated across all producers and brands, this volume often describes a curve across time, as illustrated here in figure 2.5. Although the product life cycle model does not dictate that every product will experience the same pattern of sales volume, it does clarify the fact that many consumer products have evolved through the following 4 phases. And we're going to go over each phase in the next 4 slides. So the first of the 4 phases is incubation. All products begin with an introductory phase in which a small number of innovators and entrepreneurs bring the new product to market. Now here the product, if produced and sold in small volumes and prices, are relatively high. As an example, the personal computer, the PC, was largely unknown in the world in the 1970s when hobbyists, people who were like enthusiasts about technology, were building and marketing early versions of this product. The second phase is rapid growth. A product may not necessarily survive its own incubation, but if it does, it generally enters on a distinct period of rapid growth now that the product becomes known to its intended market and more organizations enter the market to meet the new demand. For example, 3 companies, Apple, Tandy, and Commodore, introduced the 3 brands of PCs that are credited with launching this market in 1977. Sales of personal computers then grew rapidly throughout the 1980s with manufacturers including IBM, Atari, Compaq, Dell, Hewlett-Packard, Apricot, Digital, which was known as DEC, and that's about it. And they all added their own offerings to this matrix. The third phase of the product life cycle is maturity. At some point in a product's history, its providers are likely to saturate its market and demand levels off. The product is now said to be mature, and this maturity often prompts the exit of some of the businesses that joined during the rapid growth phase, while the remaining providers produce the higher volumes and compete on price. Continuing with that example of the PC, note that only a few of the companies mentioned in the previous slide continue to manufacture PCs today. Several of the missing companies closed down their PC product lines during the 1970s when slowing of the rapid growth phase first became evident. The fourth and final phase of the product life cycle is decline. And the product life cycle theorizes that any mature product will eventually move into a decline, replaced by the rapid growth of some new offering. However, if and when this decline takes place varies with the nature of the product in question and even how the product is defined for the purpose of drawing the curve. For example, if personal computers, PCs, are defined as desktop hardware, they began their life cycle as, then this product began to decline in the mid-2000s as wireless mobility of smaller laptops and notebook computers fueled the popularity as a substitute to that desktop. However, if the personal computer, PC, is defined as any personal device running complex applications, including desktops, laptops, notebooks, tablets, and smartphones, then the product lifecycle analysis would indicate that demand for this product is still growing. Now, although the product lifecycle is a marketing model, these phases have implications for process choice and operations. Note that a product usually begins as a customized output of an innovator, being scarce and somewhat costly in its early years. As figure 2.5 indicates, successful production of this product often requires increasing standardization as the product grows older, when higher demand fuels the need for higher production volume and increasing competition forces down its price. While the new products tend to be more customized and are offered in many changing formats, one trademark of mature products is a high degree of standardization that pressures its few larger providers to spend heavily on advertising to differentiate their otherwise similar offerings. One simple measure of success in operation strategy is the degree of value added in the resulting operations, or the difference between the value of its inputs and the value of its outputs created from those inputs. Now, value added is easily recognized when examining consumer goods, a gallon of gasoline being more valuable to a motorist than a gallon of crude oil would be, or a sweater more valuable to a holiday shopper than the wool fibers used as its inputs. However, value added is not always a simple issue when evaluating processes for strategic insight. Consider the case of a city fire department. We're going to use a fire department as an example. An emergency operation that is often measured by the dollars of damage from building fires within its service area. Now, a better measure of value added would estimate the department's with the dollars not damaged at each of those fires, as this is the desired result from the fire department's operations, right? So you would be analyzing not the damage, not the dollars of the damage, but the dollars not damaged for analyzing, let's say, productivity. Unfortunately, estimating dollars protected from damage during fires requires estimating dollars of damage if the fire department had not responded to that same fire, a theoretical event, and the seemingly simple issue of measuring value added is revealed to be quite complex, right? So productivity is another common measure used in the evaluation of processes and systems. Productivity differs from value added in two ways. The first being that productivity is stated as a ratio of output to input, where value added is simply the difference in those same values. Second, unlike value added, productivity is not always a comparison of the overall input and output values. When productivity is based on such estimates, it is referred to specifically as total productivity measure, more common than total measures. However, productivity are partial measures, which focus on the relationship between a particular output and input, or a broader multi-factor measure that considers a particular output compared to the value of a set of inputs, which we're going to explain in the next slides. So there are three kinds of productivity measures. You have your partial productivity measure, which is a ratio of a particular output to a particular input of an operation. You have your multi-factor productivity measure, and that's a ratio of a particular output to the combined value of a set of inputs of an operation. And then you have a ratio of the combined value of all outputs to the combined value of all inputs of an operation, being the total productivity measure. Now, calculating productivity lends transparency to the inner workings of an operation, allowing its health to be measured in terms of value creation from the resources at hand. However, like any performance measure, a productivity ratio is only as meaningful as its assumptions, and care should be taken to avoid overinterpretation of this convenient calculation. If an operations ratio drops over time, declaring that operations productivity in decline implies that its actual performance is eroding or malfunctioning. In reality, it is possible that an operation is functioning perfectly. The drop in the ratio value may be the result of one of these following factors. You have the falling demand for output, and that is the demand for output of a process is usually outside its control. Falling demand causes the productivity numerator to decrease, but the denominator may not change correspondingly because certain inputs are not easily adjusted. An operation with highly seasonal demand can naturally measure less productive during the slow season, but this isn't necessarily a fault of those managing the process. Then you have changes in the allocation of overhead expenses. Overhead expenses are business costs indirectly related to the production, such as the cost of the building or the cost of the administrative salaries. Now, because this relationship is necessary but indirect, the business must decide how to best divide these costs among its products. As a result, a multi-factor productivity analysis incorporating overhead could indicate productivity has dropped sharply when nothing has changed within the process under evaluation. The drop was in fact caused by the sale of another division, increasing the allocation of corporate overhead assigned to that process. And then you have improved quality of output. Productivity ratios assume that the output is of acceptable quality. However, blindly rewarding high productivity measures pressures employees to it pressures the employees to maintain the high output rates, which can lead to higher error rates and less time for problem solving. So if a business decides to raise its quality standards, it may need to trim the pace of production, which pressures the productivity ratio downwards. And then you have changes in demand requirements, and productivity ratios are easier to interpret in manufacturing environments where the output is designed in advance and fairly stable throughout time. Now, more caution is required when evaluating service systems because one unit of output may require more from the process than the next unit. So depending on what those customers needed, it's all about the need. So for example, a surgery team might perform 12 operations one week and 9 operations the following week because the second week's patients, had a different need, or required more time. So that is it as far as calculating productivity, lends transparency to the inner workings, and then you have to be careful in those drops in the ratio value. And looking for those factors in the drops that get a accurate productivity analysis. So in summary, we're going to go over what we talked about in this chapter. An organization begins by stating its vision, mission, and values, and these statements define its overarching goal and chosen path into the future. Its strategic business plan then translates it into that strategy into tangible actions, and these plans define the goods and or services that the organization will provide to fulfill its mission, as well as the broadly sketch how these products will be created. Choices made here should be consistent with any core competencies in the firm and as the source of its competitive advantage against other organizations. Remember the Honda example we went through earlier. It's more about the motors and the driver trains, not about the specific products like the cars, the motorcycles, the yard tools that Honda comes out with. And it will also likely be shaped by powerful ongoing trends in technology and globalization. And also, any organization completes its mission through its operations. Once a product is identified in a business strategy, operations strategy selects processes to support its production, and processes transform inputs into outputs, providing goods and services, and often many operations exist in processing, such as the degree of standardization in the chosen process. You have extreme standardization lowers production costs but reduces customer choice, and that links back to earlier choices in competitive strategies, such as a decision to prioritize affordability over customer or consumer responsiveness. Choices in operation strategy are often consistent with the product lifecycle model, which suggests that products begin as higher price custom offerings and then grow more standardized as their sales volume increases over time. And then processes of all types must be monitored for their performance in their chosen roles by comparing their actual outputs to their actual inputs in some measure of productivity. So that concludes the Chapter 2 lecture. Please sign in to Blackboard and look for this week's expectations and deliverables. And I will see you all in Chapter 3.